In this last video, we will try to understand the meaning of mixed strategy Nash equilibrium. We have already discussed what do we mean by a Nash equilibrium earlier. So this time our discussion would be limited to mixed strategy Nash equilibrium. So if you remember, we had obtained Nash equilibrium in a matching penny game, and the situation was that both player 1 and player 2 would be mixing using half of H and half of T. Same for the other player. If I write here payoff. So if let us say player 2 is mixing using half and half, and we had obtained in this case if player 1 plays 1, what would he get? A player 1 plays H, what would he get? 1 multiplied by half plus minus 1 multiplied by half, 0. T also gives him the same 0. What is happening? And then we say that player 1 will mix using probability half and half. Why does he want to mix? Because if he doesn't mix, then player 2 will have a unique best response H or T, and player 2 would not mix, and as a result player 1 would also not mix, and there won't be any equilibrium. But the point here is that whether player 1 plays H or T, or let us say 3 by 4 H plus 1 by 4 T, or 2 by 3 H plus 1 by 3 T, always it's going to lead to the same outcome for this player, and that is 0. So what incentive does he have to mix in that particular manner? So can we justify this Nash equilibrium as a steady state? Let us say in this game, what do we mean by a steady state? That let us say player 1 mixes between H and T with not with probability half and half, with something else, then we will not have a steady state. What do we mean by steady state? That is an important question in this particular setting. Steady state is that, yeah, player 1 is mixing with half and half and player 2 is mixing with half and half, then no player has any incentive to mix between H and T using any other probability. So that could be a steady state. So that what we are talking about, individual randomization, that player 1 is randomizing between H and T, or player 2 is also randomizing between H and T. There is another possibility that player 1 is coming from a population, player 2 is also coming from the population, and so half of the time people who are coming from the population, they are playing H if they are player 1, and half of the time they are playing T when they are player 1, and same justification can be given from player 2's perspective. So this is a stability in the population, because let us say if 3/4 who are coming from the population is playing H and half they are playing 1/4 remaining they are playing T, then what would happen? Player 2 will have very clear incentive to play T, and then if player 2 is playing T, then player 1 would like to play also T, and player 1 would like to change from 3 by 4 H plus 1 by 4 T to pure T, and in that sense population will not maintain this particular ratio. So in that sense we can say that these players are representing their population. Of course they are playing because of them for themselves, but they are coming from population and they are learning in the population. So two interpretation that I am suggesting: one, that individual is randomizing, half of the time he is playing T, half of the time he is playing H, and it is not pre-decided that this time what he is going to do, but on average half time H or T. But it begs another question, that is it repeated interaction? What do we mean by half of the time playing H, because this game is going to be played only once. So what I mean that in such setting player 1 would be playing H half of the time and T other remaining half of the time. This interpretation also begs a question: if it is a steady state, then is it stable? We can check whether it is stable or not. Let us look at it through two examples that we already did. One example is battle of sexes. What we had figured out, that in battle of sexes we got 3 equilibrium. What we had was AC for player 1, player 2, let us say action romantic movie 0 0 0 0 CA. What we have assumed, A is greater than C is greater than uh, this 0. That's what we had. And we had 3 equilibrium. If we remember correctly, this came out to be something like something of this sort. We had an equilibrium here, we had an equilibrium here, and we had an equilibrium here. On this axis we had P, on this axis we had Q. So let us say at mixed strategy equilibrium, they are mixing using this particular, let us say P dash and Q dash. If there is little bit of perturbation, if this increases from P dash to slightly higher number, what happens? Best response from Q at this point is this, and if Q is playing this, let us say, then best response from Q is this. So slight perturbation in this direction will take equilibrium to 1 comma 1, and what happens if there is a slight perturbation in this direction, then best response is here, that's coming from player 2, then it will take you here, and this is where you would end up. So slight perturbation will take you from the equilibrium. In this case, it is very clearly unstable. I suggest that you do exactly same thing in case of game of chicken, and in that game you will find that equilibrium is stable. So what I am trying to say, that there are both possibility that you get stable steady state or you can get unstable steady state. In which sense is stable? That you perturb the behavior of players little bit, again that equilibrium would come back, and that is a nice property. But if you remember from physics, there is a big bowl and small ball you put, you disturb, ultimately it will come back. So in this case it is a stable equilibrium. If you have the bowl in the opposite way you have kept and you disturb the ball little bit, it will never come back to the original position. It is unstable equilibrium. And for the sake of completeness, I should say that if there is a flat surface and if you disturb, it will maintain its position. This is called neutral equilibrium. But what I am saying, that Nash equilibrium that we are obtaining is a steady state. We cannot say it is stable or not stable. It does not matter. That is the first order thing that we are obtaining, that we are getting steady state. Next thing I won't be able to complete as of now because we have not studied what we call incomplete information game. It is in the syllabus, we are going to talk about it. So once we talk about it, I will come back and discuss mixed strategy as a pure strategy in the perturbed game. So these are some of the explanation that can be given for mixed strategy Nash equilibria. In next week, we will start discussing extensive form game. See you next week. Take care. Bye bye.